Alright, so today I want to try and I don't really have a goal. I guess we'll go ahead and do like a calculator or something because that'll be something that's not terribly difficult and I should be able to probably figure out on my own without any help. So we're going to first start with I guess we want to start with oops. We want to start with some pseudocode. So we're going to have to functions of add, subtract, divide, and multiply. We're going to want to take an input and return an output, the solution. Maybe we print problem, and that should return the solution. So we're going to so to define add. We'll take an input a plus b. No, we'll do a and b. We'll do a plus b. Oops. Alright, so we'll do problem, we'll do print, we'll do add 2 and 5. Let's run this. We have problem a dot, oh, that's supposed to be a comma. A plus b. Okay. Line 6 having a problem. Okay, I think we need to do C equals A plus B. I think if we do this, then it should fix 7, print 7. Good. So, we're going to want to also, well, let's do 2 and 5 every time. But we'll do maybe we do 5 too. Or let's do even 6 too. Right, because 6 and 2 should be 8. If we do 6 and 2, subtract, it'll give us 4. If we do 6 and 2, divide, it'll give us 3. And if we do 6 and 2, multiply, it should give us 12. So then let's go ahead and define subtract a. We want an A and a B. We want to do C equals A minus B, return C. Define divide. I don't know why I did divide before multiply. That's kind of weird. Anyway, A comma B. We're going to do A divided by B. Okay. C equals return C. Something happened here. Return C. Then we're going to do define multiply A B. We're going to do C equals A times B. Return C. And now if we go ahead and run this, it should give us all of our answers. a plus b is 8. Subtract, it goes 4 times divide. 65 divided 2 is 3. It gives us as a float. Maybe we do divide str. Or I guess we'd want integer, huh? I guess we'd want integer. Can't do that. What if we go ahead and print the integer of the divide function? Kill the terminal once again. Oh, this was not supposed to be here. It should be print integer of. There, that's what we want. So now we specify that we want an integer, not a float, so it gives us 3 as an integer. Multiply 6 times 2 gives us the integer of 12. So awesome. Now I guess we wouldn't really want the integer. I just wanted to test to see how we'd find that. Because we would want a float. Because say for example we do, well, if we do 8 divided by 2, right, which is not a whole number, we get, oh wait, I was thinking this is a 3. Right, I was thinking it was 2.666, but if we did do print integer, and we ran this, it just gives us 2 now because we don't have a remainder. So it just says 2, even though it's going to be almost 3. It's going to be 2.66, 2.6 repeating. So interesting, good to know. That's how we do that. But this is how we want it to function. And any number we input, we could get a different, like for example, if we did print the output of, what if we do subtract, and we'll subtract from 1800, we're going to subtract 1482. Right, and if we run this, then we will get 318, that's right. Alright, and if we do multiply, if we multiply them together, we can test it with this here. Alright, so 1800 times 1482. Oops. 1482. 2.666 66760 mil. Yep. Alright, so we have a functional calculator. We could always add like squares and square roots and more complex diversity, but I just wanted to see if I could do this, and I guess it was actually even easier than I thought. That was kind of easier than the rock, paper, scissors. So perhaps I should have started with this and done rock, paper, scissors as a second challenge, but this actually proved to be even easier. So let's see, for line efficiency, what could be the shortest this code could be run at? 13 lines, because you have to have an input line. So it only takes 12 lines to code the functionality of a basic calculator. The 13th line is just your input. So there you go. Yeah, there you have it.